All right, today we are tackling one of the biggest challenges in AI right now. How do you build these incredibly powerful autonomous agents that you can actually trust? We're going to break down the core engineering principles for making AI safe and reliable. So let's just dive right in with the fundamental question, right? When we create AI agents that can basically think and act for themselves, who is really in control? How do we make sure they do what we want? And just as importantly, don't do what we don't want? Because let's be real, without the right controls, AI systems can become exactly this. They can be unpredictable, totally unconstrained, and yeah, potentially hazardous. We're talking about generating biased content, getting tricked by hackers, or taking actions that just completely shatter user trust and cause real-world problems. And this whole issue, it has a name. The industry calls it the unconstrained agent problem. It's this massive challenge of letting a powerful tool operate on its own. And to even begin to solve it, we first have to get a really clear picture of the risks involved. And the potential for damage here is just enormous. We're not just talking about the AI getting a fact wrong. No, we're talking about it generating genuinely harmful stuff, or falling for these so-called jailbreak attacks that trick it into ignoring its own safety rules. These aren't just technical glitches. They destroy user trust and can cause serious legal and reputational nightmares for any organization. So how in the world do we solve the unconstrained agent problem? Well, the answer, and it's fast becoming an industry standard, is to build what are called AI guardrails. Now, this is the really crucial point here. Guardrails are not about dumbing down an AI or making it less powerful, not at all. It's about guiding that power, channeling it so it's productive, safe, and trustworthy. Think of them like the guardrails on a highway. They don't slow you down, they just keep you from driving off a cliff. Okay, check this out. This design pattern really shows what a good guardrail system looks like. It's not just a single gate. It's a whole process, a continuous loop of defenses. You can see the flow here, right? It starts by checking the user's input, then the agent does its thing within a set of rules, and then, critically, its output gets validated before it ever gets sent back. If it fails that check, the whole process can start over. So a really robust strategy layers these defenses like a fortress. First, you've got input validation, basically blocking malicious prompts right at the front door. Then you have behavioral rules that guide what the agent actually does. Tool restriction is so important. It stops the agent from doing things it has no business doing. And after all that, output filtering is that one last check for safety with the human ready to step in for the really tricky decisions. And this isn't some theoretical, far-off idea. Guardrails are already mission critical in so many of the AI tools we use every single day. From that customer service bot that knows not to use offensive language, to an HR tool that's specifically designed to filter out discriminatory bias when it's looking at resumes. So how does this actually work in practice? Let's look at a couple of key patterns that developers are using, like right now, to build these safer AI agents. We can pretty much boil it down to two really easy to remember patterns. First, you've got the bouncer pattern. This is exactly what it sounds like. A separate, specialized AI that acts like a security guard, checking every user input for trouble before it even gets near the main system. And then there's the chaperone pattern, which is more like getting permission before you do something important. It validates what an agent wants to do right before it's allowed to use a tool. This right here, this is a perfect example of the bouncer pattern in the wild. It's a simple prompt that creates a specialized agent whose one and only job is to enforce content policy. By having this single-purpose agent screen everything first, you get a super fast and really cost-effective filter for bad inputs. The chaperone pattern, on the other hand, gives you this powerful just-in-time check. In this example from Vertex AI, a little bit of code runs right before a tool is used. All it does is check if the user ID in the request matches the user ID of the person who's logged in. If they don't match, action blocked. It's a simple, elegant way to prevent the agent from misusing its tools. Okay, so let's zoom out for a second. These patterns are fantastic tools, but they're part of a much broader, more fundamental strategy for building AI that you can actually count on. And here is maybe the most important insight of all. Building a reliable AI agent isn't some kind of new age magic. It is an engineering discipline. It demands the exact same rigor, the same proven best practices, like fault tolerance and testing, that we use to build any other piece of complex software. First up, modularity. Instead of trying to build one giant monolithic God agent that does everything and is impossible to debug, the best practice is to create a team of specialists. You might have one agent that's great at finding data and another that's an expert at analyzing it. It makes the whole system so much easier to build, test, and maintain safely. Next, observability. You can't trust what you can't understand, right? So we need deep, structured logging that captures the agent's entire chain of thought, what tools it called, what data it looked at, and its reasoning for every single step. This is absolutely essential for debugging and actually making the system better over time. And finally, we apply a core security concept, the principle of least privilege. An agent should only have the absolute bare minimum set of permissions it needs to do its job, and nothing more. An agent that summarizes public news articles should never have access to private user files. It's common sense, and it drastically limits the blast radius if something ever goes wrong. Okay, we have covered a lot of ground. So, what are the most important things to remember from all this? Here's the bottom line. Guardrails are not optional anymore. They are a non-negotiable part of responsible AI development. A multi-layered defense is always going to be better than a single point of failure. And fundamentally, we have to treat building these agents with the same engineering discipline we'd use for any other production software. That's how we build systems that are not just powerful, but also trustworthy. And that leaves us with one final, pretty thought-provoking question. As we get better and better at engineering these safety systems, we have to start asking, what are the core principles and values we're building into them? Because a guardrail is only as good as the rules it's designed to enforce. And those rules have to come from us.